Welcome to Haskell Field School. Today we are looking at plan reading and how you can be in the know. So sit back and get your pen and paper ready because it's time to dive in. One of the greatest foundations you can have in your career is the ability to read and visualize the plans and take that information and apply it out into the field. A project with multiple scopes of work and play can be a challenge. We need our craft to be prepared and able to read plans and use that information to construct out in the field. A person that can read plans is able to communicate how to construct elements found in the plans to his or her team. This training is to help you begin to use the plans to create a 3D image in your mind so you can better plan your operations and communication in the field. Objectives today are 1. Understanding the plans. 2. Understanding the structure. For example, how do we take these 2D drawings and communicate that in our three-dimensional world? 3. How the architectural plans correlate to certain scopes of work that may be on other scope plan pages. For example, how MEP drawings and shop drawings are used with the architectural plans and how to take all this information to coordinate our operations. And finally, how to create a work plan and use it effectively in the field. Today's lesson is based on the ARC project. This building will serve as an adult resource center and as the local hurricane shelter in Northeast Florida. Let's review these plans together to gain insight on how you can sharpen your plan reading skills. So pull up the set of plans provided and let's get started. Feel free to pause this video as much as you need and give yourself enough time to work through these drawings and exercises. We want you working at your own comfortable pace. Navigating the pages is key. Like everything in construction, time is everything. You can flip through one page at a time, but that is not very effective. We need to get answers fast to our crews and subcontractors. Losing time is losing money, so an effective plan reader is one of the most valuable skills one can possess in the field. Here are some key pages that will help us greatly to navigate the plans. Let's take a deeper look at these examples. I was going to start with the first page, the cover page, but this page is the most important, the sheet or plan index. This is found in the general sheets or G sheets. They contain the cover sheet plan index, plot plans, general notes, partition types, and life safety plan. This page will help you quickly find what you are looking for. Don't waste time going page by page. Go to the source. The cover page. When you first examine a set of prints, the title and cover page will give you the preliminary information you need to make sense of the rest of the plans. The page contains the plan index and reference list of all the drawings contained in the set. Any changes made to the plans are listed in a revision block that's typically located in the title block. Read these items first to understand the scope of the building and any relevant information about the architect. The title block is a rectangular box usually present either at the bottom or on the right-hand side of a drawing sheet. This box contains various information such as the title of the drawing, scale, the logo, or information about the company and people associated. The project, which includes name, address, and date. This helps in tracking the revisions made over time as this drawing goes through several changes, and those changes need to be checked upon regularly. An architectural seal is provided to prove its authenticity, which should have the signature and license information of the architect in charge. Thus, a title block gives you an overview of the project you are working on and data available on the sheet, which makes reading, identifying, and verifying it easier. This in turn enables a smooth design process and the constant flow of drawing information to be measured and maintained. Each discipline will have their own general notes page. Although most abbreviations and symbols are usually the same most plans, some may have abbreviations and symbols that are either different or may be unfamiliar. This page will help greatly to understand the plans. When learning how to read construction plans, one of the most important components is the symbol legend. The legend is used to define the symbols used in the construction plan. General notes eliminate the use of lengthy written explanations and provides technical information that will apply to the entire drawing. Here's an example of the necessary information you can get from the general notes. The rod busters are asking you for the clearance of the rebar in the formwork of a beam we are constructing so they can start placing their bars. Most of us know the clearance is crucial to the longevity of the structure and should be checked for quality assurance before the placement of the concrete. Let's look at the general notes under concrete for the answer. And there it is under beams. Let's go tell the rod buster crew that the clearance is 1.5 inches off the form so they can go ahead and get started. Those bars are not going to tie themselves. Let's look at the partition types page and see what valuable information we see. Here we have general notes just for the partition types as well as details showing us a bunch of information. Let's look at partition type 18. Look at all this information. In the legend, we have the partition type. You can see the number in the box, which we will find those symbols on the architectural floor plan to help us identify the walls. Next on the legend is what the wall is made out of and size. Next box over is the wall rating. And lastly, an additional note box. Make sure your subs put down the right acoustical sealant as per the details and that they check the details for all wall conditions. Last thing we want is to have the inspector fail us because we did not terminate our walls correctly. This page is very important, and items on this page will be inspected thoroughly by an inspector before we can get a certificate of occupancy. The dotted lines are the expected travel distance and egress travel route to get out of the building and will be part of the emergency plan for the building in case of fire or any other reason for evacuation. Another item on this page that will be important is the location of the fire extinguishers and type, which may not be on the architectural set, which means these locations will have to be coordinated out in the field with whoever is constructing the partitions and exterior wall. Read this page thoroughly. We don't want to fail an inspection because we failed to order the right fire extinguishers. I think you are getting the hang of this. Let's practice what we learned with a class activity. Using general notes, identify the spacing of the vertical rebar in the cells of the CMU. Then identify the lintel on detail 1, S301. From there, find the CMU lintel schedule. For lintels measuring from 41268, what is the depth those lintels should be? This building has several beams that are integrated within the CMU wall. What detail on this page is that information, and what is the minimum bearing that beam is required to have to be placed in that wall? Lastly, what is the PSI for the masonry group? Did you get all that? Pause the video and get to work. The next time you do this, you may have a crew waiting on you so they can get their job done. As the GC, we are the stewards of the project. What this means is that we must be able to visualize the structure and be able to communicate that out to our team so they can build it right. Not everyone is an expert plan reader or coordinator, and most of the craft and subs are going to have questions. They are going to have questions. They are going to need help to get their job done with the least number of conflicts during construction. Being able to visualize the structure and communicate does just that. After all, here at Haskell, we want our jobs done right the first time. And when I say we, I mean the subs too. Before we can successfully lead crews to build the structure, we need to practice how to visualize the structure so we can communicate the intent and constructability of the structure's design. Here's how I begin the process of visualizing the structure. First, I start with footer locations and their relationship to column lines. Then I use cross-sections from architectural to gain deeper understanding how the structure is built. The cross-sections are a big help. Then I correlate the floor plans with the exterior elevations so I can start to see the big picture. After I have a rough idea of what I'm dealing with, I start to look at general notes to gain knowledge of the materials and design intent. At this point, I'm starting to wonder what else may be involved, so I pull out the specs and get a general overview of all the scopes involved. Wow, that is a lot of information to process, so make sure you have a notepad handy. Let's look at the footers and column lines. Pause the video and pull out SU101 and A110. Looking at S101, we have highlighted the footers by type and size. The isolated footings are the Fs. They will have the column bearing down on them. The wall footings are the WFs. These are the wall footings where the CMU will be constructed. Now locate the column lines that we will be using. Not only will these identify the columns, but they will be control points which we can measure off of. Always use both the foundation plan with the overall first floor plan when planning out your foundations. You will be surprised at the number of dimensional busts you will find when looking at these pages. If you find a bust or a dimensional mistake, Bring these busts up with your superintendent so we can get the right information from the right source. Sometimes these busts are less than an inch or as big as a foot. Remind yourself that there are two different firms making these drawings, one being the structural engineers who puts together the structural drawings and the architectural firm who produce the overall design. Mistakes happen. It is our responsibility as the GC to make sure we do our due diligence in coordinating all these drawings so that we end up with the desired end result. Still having trouble visualizing? Let's review the cross sections. Pull up A302, Detail 2. Here on the screen we have both the cross section and a shot of the structure during the joist installation. Look how they match up. The only thing we are missing are the suspended ceilings and the partitions or walls in non-technical terms. I apologize for skipping ahead. I forgot to talk about the cross-section symbols. Here are some typical plan symbols to show cross-sections, elevations, and enlarged plan areas. Each symbol has the page and the detail number in the circle. The line shows the distance of the section, and that small black triangle under the circle indicates which way you are facing. The symbols that have the dotted rectangle are areas that will be an enlarged floor plan section on a different detail to show more detailed information. The circles with no lines and with the 4 points are symbols that will bring you to an elevation. Again, the points of the triangle are the direction you would be facing if you were standing where that symbol is on the plan. Final step that I can help you with is how to correlate the overall floor plan to the exterior elevations. To get a good mental image of the structure, we need to understand the wall heights and other important elevations like joist pockets. What about seemingly simple but complex stucco designs? We need to know this information inside out in the field and on the paper. Now that you have an idea of what the structure looks like, we need to start pulling information from the plans. The plumber wants to check if they have enough overflow drain discharge trims. According to the elevation drawings, how many are there? It takes at least 3 weeks to get the scaffolds here for the masons. We need to get an order in for scaffolding. The vendor needs to know the height of the tallest wall so she can check her inventory. What is that dimension on the plans? Also, what is the perimeter of the building in linear feet? You just received a phone call and the iron worker needs to clarify the height of the bottom of deck for the height of the bottom of deck for the main and low roofs. And now we come to find out, the block mason does not have access to the architectural plans and needs the window and door dimensions for all of the openings. You better double check their dimensions out in the field. What size and type wood buck needs to be installed before storefront, and is the door frames grouted in? That is a lot of information to hand out right after the 7 a.m. meeting. Good thing you like to stay busy. Hit the pause button and find the information. Questions come up and we need answers. After all, we are building someone else's design, which again is designed by multiple architectural and engineering firms. Because of this, some things can become unclear, like an electrical box with multiple conduit in one of our CMU columns. There's nothing structural about plastic conduit. So we need to ask this question formally by issuing an RFIE. This request needs to go through both the superintendent and the project manager so they can see if they can solve the problem, and if they can, it heads out to the architect or engineers for some clarification. Communication is key, so make sure you can indicate where on the plans the issue is located, and as always, pictures help. All right, showtime. We have enough invested in reading this set of plans that we can start a work plan for the foundations. We understand the foot and locations, dimensions of the footprint, and the column lines. We can't waste any more man-hours on cleanup. We have to put our crew in action. We need to make a schedule and start getting the crew warmed up on equipment by getting the site in order and start marking out the foundations for excavation. Let's huddle up with the team to talk about the hazards and then get with our surveyor to pick a starting point for the foundations. Then let's get everyone moving and the operation staged. While they are working on that, let's plan the next steps. Next up is type of layout and grades. Rebar, how much concrete needs to be ordered. Then huddle up again to share the information. There are various ways to lay out a building, whether it is the older school method or by GPS. The job has to get done. Let's look at the old school method. Happens 2 ways. The first, A surveyor lays out secondary control points off of established primary controls, such as installing hub and tack to identify the column, lines, and exterior wall face lines with offsets. Second, we set up batter boards and string lines with a theodolite, also called the transit and laser level. With batter boards, we use less established points by the surveyor and create building points of our own, like measuring off of a single established column line and making our own building controls to measure from. Or we can use technology like a Trimble to set established building points directly on the ground to build and measure off of. You are always going to have to understand the use of offsets, column lines, and exterior wall face lines to build the structure square and efficiently, and most importantly, right the first time. Now that we picked the layout type, let's continue to work on our work plan. If you want your team to be a success, you're going to have to give them all the information they need and be able to answer questions as they need them. Let's mark up our plans for our work plan for the field to use. Okay, how many types of footings are there? Identify them on the plans and highlight them so there is no confusion. Next up, what column lines gives you the center of the F8 footings? We will need to quality check these dimensions. Steel isn't that forgiving, and epoxied anchors are never as good as embedded anchors. Speaking of steel, our authorized forklift operator is going to need to know where to stage the steel being delivered. Which footings get the 4-inch steel columns and which ones get the 6-inch. Lastly, our field team is having trouble with the depth of the footings we are excavating. Knowing the finished floor elevation, provide the depth of each of the footings so they can get back on task and we can plan for what's next. You may be wondering what a work plan is. Well, a work plan is what you make it. Personally, I have found that putting all the information on an extra plan sheet works best. The sheet can be used to help identify certain elements like you see here with the footings, but it can be much more. We can also have areas marked up for staging, concrete quantity calculations, and whatever else helps communicate the plan to the team. You are in charge of your own success. And to be one of the leaders out here in the field, you have to find the best way to communicate all this information. Let's get back to work. We already have highlighted to footing locations for the work plan, and now we have to take a closer look at reinforcing and concrete. After that, we have to get ready for the masons. Let's look at the F8 footings. You will see columns in the schedule for both the top reinforcing and the bottom reinforcing. Notice how only a couple of footings get a top mat. We also have a column for long ways and short ways. Short ways being the smaller dimension of the footing. The F8 footings are square, so both ways are even. For the continuous wall footings like WF4, the short way will be 4 feet minus the clearance noted in the general notes. Can you find what the clearance is? We don't want the rebar to rust inside the concrete because we couldn't get the clearances right, and we all know what happens when the rebar rusts inside the concrete. Pretty straightforward. Now let's look at some of the more complicated rebar drawings. The shop drawings. The shop drawings can vary depending on the company creating it. These are based off the structural plan, so they may not note everything you need. The shop drawings are meant to be cross-referenced with the structural. But what all rebar shop drawings have in common is a bar list. We will get into greater detail about rebar shops and the bar list in another separate rebar course. But that doesn't mean you can't get ahead of the game and ask your superintendent or foreman to show you their shop drawings and how to read them. Anyway, now you can use your knowledge of cross-sections to dive into these shops to start to see what these walls are made out of. You may say to yourself that there's a lot of rebar here, and there is. Remember, this is a rated hurricane shelter, and there are different loads, like wind, acting on this structure as a whole. Okay, excavation is underway. Before long, the team will be far enough ahead to start dropping rebar in the hole. If you were wondering when we should start tying the rebar, the answer is now. Let's write down some information our crew will need to add to our work plan. Before we start tying the rebar, we need to check the clearances of the rebar from the ground or from the form so we can find the dimension of the rebar cage. Now that we know the dimensions of the cage, how many bars do we need for each footer and what are the sizes? Once the mats or cages are in the ground with the right clearance, we must think about how our masonry wall is attached to the footings. What are the spacing for the dowels and describe the rebar in the corners? For extra credit, tell me the locations of the bond beams and elevations. This should keep you busy for a while, so pause the video and I will see you in a bit. Okay, now we have our excavation crew finishing up the trenches for the footings and another crew tying rebar and dropping the mats and cages in the hole. 2 carpenters are placing dowel supports and the rod busters are carefully placing dowels so that they end up in the specified cell of the concrete masonry unit. Masons are chomping at the bit to get started and we need to place the concrete ASAP. We are not in the business of wasting money, so we need to accurately calculate the concrete and double check our concrete submittal with what is specified on our plans and specifications. Let's take a deeper look at quantifying concrete. We calculate concrete in cubic yards, but our plans are in feet. First, we will need to know the equation for volume. Volume is length times width times height. So, how many cubic feet are in a cubic yard? A yard is 3 feet long. So, a cubic yard has a length of 3 feet, a width of 3 feet, and a height of 3 feet, giving us 27 cubic feet. Remember this number. We will be using it again. Okay, armed with this knowledge, let's put it down on the work plan. Looking back on the footing schedule, we can see we have been provided with most of the information we need. The isolated footings are easy, but the wall footings can get a little tricky. Let's calculate the F8s together and then you can calculate the rest. According to the footing schedule, the F8s are 8 by 8 by 2 feet. Let's plug that into our equation. We should have an answer of 128 cubic feet. Do you remember that number from before? That's right, 27. We know that there's 27 cubic feet in 1 cubic yard, so take your total of 128 cubic feet and divide that by 27. If you come up with 4.74 cubic yards of concrete, then you are correct. So, if your superintendent decided on placing just the F8 footers for today, we know now that we will need to order close to 19 yards of concrete including waste. And if you are pumping the concrete, add an extra yard for the pump. Now, using the dimensions on your plans, calculate the amount of concrete needed for the footings. For a bonus, how many trucks do you think it will take to place all this concrete? Hit the pause button, and I will see you in a bit. Alright, I think that is enough for today. For part 1 of this series, we have made it all the way through the footings. Remember to ask your superintendent or foreman for help if you have any questions. Keep up the good work and remember, practice makes perfect. I'll see you next time for part 2, where we go vertical and complete the envelope. And as always, be safe.